Couple ways to do this problem. The first way you might not have thought of is to do the polynomial division first. First, x divides into x squared, x times, and x times the divisor is x squared plus 5x. Subtract. Now x divides into negative 6x, negative 6 times, multiply negative 6 times the divisor, subtract. So the remainder is 30, so our answer is x plus 5 divides into x squared minus x minus 6 times with a remainder of 30, so plus the remainder divided by the divisor. Okay, so we can rewrite h as x minus 6 plus 30 divided by x plus 5. Therefore, h prime of x is 1 minus the derivative of 6, which is 0, plus negative 30 times x plus 5 to the negative second power, using the power rule, multiplied by the derivative of the inside part, which is just 1. So the second derivative will be h double prime, which is the derivative of all these terms with respect to x, which is 0. And then the power rule, negative 2 times negative 30 is 60, x plus 5 to the negative third power, multiplied by the derivative of x plus 5, which is 1. This is it. So our second derivative is 60 over x plus 5 to the third power. But I did say there's another way to do this problem, so let's do the other way, which is using the quotient rule. So it's the derivative of the top times the bottom, minus the derivative of the bottom times the top, all divided by the square of the bottom, or low d high minus high d low over low squared. Here we go. The denominator times the derivative of the numerator, or low di, minus high d low, so high d low, all divided by the square of the denominator. Okay, let's simplify this a little bit. So simplifying this all, we get this expression. So let's do the second derivative. We'll do the quotient rule one more time. Here we go. Low d high minus high d low the derivative of the denominator is 2 times x plus 5 to the first power, and then times the derivative of x plus 5, which is just 1. So all over low squared. I think we're finding something out right now, which was doing the polynomial division made this problem a lot easier, because this is our second derivative and it doesn't look to be represented anywhere yet. So we've got more work to do if you go this route. Whew, that polynomial division is looking awfully nice at this point. Okay, we got that. And going a little further, what do we get? Okay, so a lot of things canceled out. Now we can factor out the 60. Get x plus 5. Just about there. The second derivative is 60 over x plus 5 to the third. Which is answer A. But let this be a great example. When you have a rational expression and the degree of the numerator is bigger than the degree of the denominator, there's a pretty dang good chance that the fastest, easiest way to do the problem is to first rewrite this by dividing the denominator into the numerator. So go back and watch the first 2 minutes of this video and review polynomial division if you need to. It's going to be a really nice tool to use during the course of this year in BC Calculus.